I would say there are a number of corresponding levers to make a system infrastructure for remote meter reading economically viable. So, the skepticism of utilities, especially those working in critical infrastructures, is, on the one hand, understandable, but from our perspective, actually unfounded if appropriate measures are taken, even in public networks. One example, of course, is encryption. LoRaWAN actually offers a security architecture on two levels. One is the security of the network transmission layer, meaning between the sensor and the network management server. On the other hand, there's the application layer, the so-called application layer. This means ensuring that the usage data only reaches the user responsible for it. So, LoRaWAN includes security architectures through encryption and access concepts to ensure that data only reaches the authorized recipient. Furthermore, there are, of course, ways to increase security within networks. One example would be operating your own private networks, meaning not relying on public ones, but instead, as a municipal utility, building your own private LoRaWAN network. And of course, there are also additional security mechanisms, such as VPN, so additional security layers to once again ensure that data is safely transmitted from A to B. Device management solutions are of great importance today for an efficient rollout of systems. When we look at new technologies such as narrowband IoT, they rely on modern device management solutions that make it possible to update systems in the field securely. For example, to supply them with new functions, or to change configuration settings remotely, for instance, to parameterize Telegram content remotely. So here too, modern device management solutions are essentially indispensable for enabling customers to have fast installation processes and to operate the system safely and at scale over time. In fact, we see, driven of course by European regulations, that cybersecurity guidelines are becoming increasingly important. Perhaps in the past they only applied to large companies, but now they affect everyone. Take, for example, the Cyber Resilience Act, which requires every manufacturer to implement appropriate security by design measures in their devices, to properly document security mechanisms, and to provide the ability to update systems in case of errors. This means that manufacturers face additional requirements. But additional requirements also arise, for example, under NIS2 for infrastructure operators. So with these new regulations comes the obligation to operate systems in a cyber-secure way.
Geht vor allem einher, die Systeme dann cybersicher zu betreiben.
I would say there are a number of corresponding levers to make a system infrastructure for remote meter reading economically viable. The first point is certainly standardization instead of individualization. That means focusing on manufacturer openness and interoperability, on standardized solutions that enable plug-and-play, simple installation, without extensive customization. Next is certainly a modular system architecture. That also means considering what can be done beyond mere remote meter reading when building a reading infrastructure. What else can perhaps be achieved with it? Which other stakeholders in the city, in the municipality, in the district, or in the building can I involve? Who else might be interested in data? That, of course, creates new business models. Then it's also important to already consider the optimization of operating costs. Here, the biggest levers are process automation. That means collecting data automatically, but also considering automated interfaces right from the start. How can I automatically transfer data from the gateway to the server? How can I transfer data from the server, where all data accumulates, automatically into my downstream processing systems? That is, of course, a major cost driver. This means that when starting a project, Interfaces should be one of the first topics to address. Otherwise, projects often start without automated interfaces, resulting in very high process costs. But if automation interfaces are considered from the beginning, initial costs might be a little higher, but over time, the system becomes much more efficient. It's also important to consider total cost of ownership rather than individual or one-time costs. That means, what will it cost to operate the network over several years, or even a decade? And then take into account what ongoing costs there are. What one-time costs are there? Consider the total cost approach, including installation, maintenance, and system operation. What recurring costs do I have for systems? And then, for economic viability, also consider discussions with government entities. Are there funding opportunities? There are a number of funding programs that can be used for modern smart city system architectures. So it's also worth considering what external financing sources I can tap into. And once the decision is made to build a reading network, it's crucial from the very beginning to think about a sharing approach. That means also making my network available to other players who can use my reading network so that I, in a sense, become the data processor and data distributor, and accordingly can bill my customers for the data distribution service. That allows for the creation of new revenue streams. I would say plug and play is truly a key success factor today. When you look at systems in municipal utilities with several thousand sensors, or in large residential projects in sub-metering, installation effort is significant, whether in new construction or retrofit projects. And the simpler the systems are to install and commission, the faster the system is up and running, the faster billing can be handled, and the faster system optimization becomes possible. So plug and play is essentially indispensable today for a fast rollout. Often the on-site specialists capable of configuring devices are no longer available or increasingly hard to find. That's why it's crucial to have a way to install devices easily, connect them quickly, and ensure that the data reaches the target system rapidly so that any on-site errors can be detected quickly. If devices encounter errors and not all can be received, a plug-and-play installation allows for quick identification of where data gaps exist, where there might be defects, or where anomalies occur.